star node. The only difference in this and C++ would be you don't pass the star. That's all. I think we'll see. Okay, so for that we'll say for integer I is equal to 0, I is less than node arrow children dot size I plus plus delete node arrow children dot add I, and then delete node. Okay, so this is the function. Node A will call all its children. All its children will call all its children. After it has reached till the end, it will delete itself. Then it will go back here. It will delete itself. So this recursively gets called, and all the trees, all the nodes get deleted. Okay. So far so good. And then we will add a string. So let's say the node is there, and we want to add, I don't know, TED, TED. So we will pass add string and string SG value.
So Ashish,
Yes.
how do we get rid of the word in front? It's like TED is complete now. How do we know
So
it is completing at D?
Yeah, I will actually write code for that. So when it is the last character of that array, I will put is end character is equal to true.
But that can further extend that.
Yes.
That can be further
That can be
extended.
further extended. So let's say TEDDY. So this is an end character, which is
Right.
true. This is false, and this is true.
Right.
So okay. Okay. A tries node star current is equal to root.
This way you can just do lot of sentence and also
Yes.
complete intelligent system we can develop.
Yes. But then you would have to do optimization and not use vector and array list and do all sorts of crazy things. But, yeah. So because okay, for integer I is equal to 0, I is less than SG SG value dot size I plus plus. So what we are going to do is we are going to loop through the entire string. So TED. So we'll go 3 times. Okay. First time we'll say A tries node star child is equal to find node current. Okay. Current comma SC value dot add I. So what we are doing over here is first we actually initialize current to root. Then we will go through this and we'll say, okay, child, find a child which has a value t. There is nothing. If there is nothing, create a new node. So if child is equal to null. So if child is equal to null, which means I didn't get anything, I will create child is equal to new A tries node, and then child arrow data no C value over here is equal to SG
value
add I, and then we will check if I is equal to SG value dot size minus 1. We'll check if this is the last character. Then we will make child arrow is
and equal to
end
true.
is equal to true, else child arrow is end is equal to false. Okay? If the child is null. If the child is not null, what we will do is we will make current is equal to child. Oh, if t already exists, I don't need to add a new node.
Right.
I will just make current is equal to t, and then I'll go through all the child of t, and then check if e is a child. If e is a child, I will just make current is equal to e. Otherwise, I'll create a new node e, and then add that.
So you are maintaining tail to add a new element if required.
I am maintaining current first was at the root, then it will go to t, then it will go to e, then it will go to d, and after d, like everything, the size is done, I'll just return. So that is what.
So this is the case with one node. With TED, suppose there is another name, then
Okay.
how current will be?
Okay.
in that?
So let's say TED was already added. I will
Now
add
current,
t.
your current is at the end of
Huh,
TED.
no. Current is no. This gets added called every time.
Okay.
This gets called every time. So in my main class, I will instantiate a a tries, and then I will call a tries arrow add string this one. A tries arrow add string t, a string add TED, and stuff like that. So yeah. So every time current will be actually going to the root. And
So in case of TED is already there.
TED is already there. Current first is here. It finds a t. Current becomes t. It finds a e. Current becomes e. It finds a d. Current becomes d. Now it does not find d. I'll create a new node, make this as false, and then add this to the children. Add this to the children. And where am I adding this to the children? Am I adding? Yeah.
Yes.
Okay. I forgot one line over there. So current arrow children dot push back. So for children's, I will in that array list I will add another children. So that is the line which I missed over here. Yes? No? Sannata?
Yes. Yeah.
Does anybody understand? No?
Yes.
Kind of? No? Doesn't make sense?
It makes sense. It's just if it's T, like suppose you have TED,
Mhm.
what you're, I think maybe because of writing I just missed it. T, you search for T. If you don't find T, you create a new node, right?
Uh-huh.
The next thing you do is
Next thing I'll do is make current as
equals child.
child. So child is T now.
Child is T. Okay, then you look
Then
at the
I'm-
subnodes that if it
Yeah.
exists or
So
not.
child now child will not have any nodes.
Yeah.
So I'll create another one.
But if it's suppose if T had A,
Yes.
Then you.
I will
actually draw it.
condition.
I will draw a proper
like suppose you already had tab or tab something.
T and then E and then D is there. Okay. Now what do we want to add?
Let's add tab.
TAB. T-A-B. Okay.
If
Yeah.
you will add
So
TED,
T-E-D.
the double DDY.
E.
So 3 iteration
Y.
will go
So-
traversing the first 3.
Yeah, so first time I will instantiate a try.
T and
This will be null. Second time I will say TAB. So it comes over here, it does not find any nodes.
right.
It will add T. It does not find anything, it will add A. It does not find anything, B. And then makes this as true, that this is the last one. Then you add TED. So T comes, it finds T, current becomes equal to this. Then it tries to find E, does not find E, creates a new node. Then current becomes E. Then it again does D, adds a new one, and then this is true. Goes out. You trying to add Teddy, so it comes over here, finds T, finds E, finds D, then it does not find another D, you add new node, you add a new node and make this as true. Yeah.
So this find node just looks. How does your find node work?
Find node, yeah, I will implement
Okay,
find.
you will implement.
Find node is also
Yes.
very simple. It just goes through all the
nodes
child
or
nodes.
Just the immediate level.
Just
like-
immediate level.
like
Just the
right
immediate
below
level.
it, right?
Just the immediate level.
Okay.
Not
Not
below
the
that.
whole.
Not the whole
Yeah.
thing. Yes.
Ashish, when you at the last DY, so at the third, at the first D, you remove the previous.
No, I do not remove that because like if somebody has to search, they can say TED
Okay.
is still a word.
Okay.
So if they want to say like I want to find all the words which
start with T.
which starts with TED, like the autocomplete search. So when you do autocomplete, like you type TED, it will start giving you all those values. So it will reach to TED and then give all the possible combination of this particular tree. So that is, yeah, okay. I will.
That is the logic behind Google.
No.
Not really. This is. They. The autocomplete does not work that way, but yeah, sure. Okay. So I write the find node, which should be very easy. A tries node star child comma character C, or I should write node actually. So find node, what it does is it goes in all its children's
Right.
and then finds if it has that character or not. So for integer I is equal to 0, I is less than node arrow children dot size I plus plus, and then it says a tries node star child.
You will call it recursively?
No, I'm just calling it's a list. It's basically an array list. So I'm going through the entire array list of all its children.
So first node and all children. And what was the
Huh? No, this
the root will have n number of, let's say,
Sure.
when every children has again a children.
No, I'm not going to level behind. This find node is also this find node
So
is
this node dot children dot size will give entire.
No. At that level,
That
80.
level
So for T it will be 80.
so for T it will be A and E.
Find node will give A and E.
Find node will give
Or
find node
no,
for
will
T.
T.
Find node for T will give A and E.
That's
Immediate
okay.
Immediate.
But again you have to traverse the B and D also.
No,
Then we
this is
pass
a
A.
helper function. This is the
That's okay.
Then
Then you
you
need to
for
call it
that.
for recursive.
yeah. So
right?
that is another function. There's another
But
function.
we
तो
don't
पहले
need
वाला
a-
function
There's another function.
पहले वाला function नहीं है, उस function में वो वाला function देखो, और एक level पे अगर आपको देखना है कि एक level पे कितने बाकी की और कितने section है, वो find करने के लिए ये दो
So there is another function. Oh, sorry. There's another function which is search a word. That is the third function. This is just a this is a helper.
Such a word is the different, right? Searching a word is the entirely. Yes, we will go character by character matching, and we need to also check the
We'll
termination.
come to that. This is a
That is
helper
different.
function. We'll just finish this helper.
Okay.
Okay, and this was private in my function anyways. So, okay. So is equal to node arrow children dot add I. So I get the node and I will check if node arrow C value is equal to C, character C, return node. Otherwise, if it comes out of this, return no. Okay. So what this is doing is at every level, it is checking all its children, and if it finds a children with a value character C, it will return that node. Otherwise, it will say that I don't have any of the children. That's all it does. Yes? No? Okay. So
I have a doubt here.
Yes.
Again. I mean, how we will find the Y?
That's a different function I'm going to write right now. That is
This
called
is for only one label.
only one level. So the previous function,
Oh.
which was add a string was actually calling this function. Find node. Add a string was
Yes.
add a string
Yes.
was calling
Got it.
in my children, find if there is a node with C or not.
Right,
If
right.
there is, then I will just make current is equal to current.
Right.
If there is not, then create a new node. That is, so this function is a helper function. Now there is another public function which is search the word.
Oh, that's
That-
why you said it's private.
Yeah,
Yeah,
yeah, okay. Okay, so we will write the
ये मुझे नहीं पता पेंट वही हो जाता है
implementer.
हाँ इम्प्लीमेंट अबाउट
Okay,
So tries के ऊपर questions कैसे आते हैं?
that's what I was asking.
डिक्शनरी
नहीं,
कैसे
तो
कैसे
ये
इम्प्लीमेंट
वो ये
करोगे?
बोल सकते हैं कि भाई ऑटो सजेस्ट किस तरह से इम्प्लीमेंट करोगे एंड
Sure. They will say if you have to implement a dictionary in your cell phone doesn't have that much memory. How would you implement it and all these other things? Like they'll say something like that. You will say yes, I know there's a structure called tries, and then you will do all the drama and you will write a try structure, and then that is how it works.
short.
Okay. Search word and string sc search. So this is the function that you are looking for. Okay. So what we will do is, if we have to search a word, we will, let me see what I'm doing. Okay. And this is the Boolean function.